Question 1. In the arrow diagram on the right, function f maps set P to set Q, and function G maps set Q to set R. So the question asking you to determine A, the function of f. Now, based on the arrow diagram here, the function f that we have here is going to map x to 3x, which means the x is going to be the object for the f, and then this 3x is going to be the image of the f. Therefore, the function f(x) is equal to 3x. B, the function gf, which is the composite functions that going to map set P to set R straight away. So based on the name gf, function f is the one that going to do first, then followed by the function g. So in this case, the x here will become the object for the composite function gf, and then this 2x minus 7 is going to become the image of the gf. Therefore, the composite function gf(x) is equal to 2x minus 7. Question 2. For each pair of the functions below, obtain an expression in the form of function notation for fg, gf, f squared, and g squared. So from the question A here, we have a function f which is equal to 3x and a function g which is equal to 3 minus x. So for the first one, we're going to solve for the composite function of fgx. So fgx is mean we are going to substitute the function g into the function f. So the function g that we have here is 3 minus x. So this 3 minus x, we're going to substitute into the x in our function f. Then we're going to expand this. So we're going to get 9 minus 3x for the function fg. Then we continue with the composite function of gf(x). Now this means we are going to substitute the function f into the function g. The function f is 3x. This 3x we are going to insert into the x in our function g. So we are going to have 3 minus 3x, followed by f squared. The function f squared is means we're going to insert the function f into the function f. Function fx is equal to 3x. This 3x going to insert into the x in our function f3x again. So this is what we're going to get. Multiply it, then we're going to have 9x. Last one we're going to do for the g squared x, which means we're going to insert the function g into the function g. So the function g is equal to 3 minus x. So we're going to substitute this into the function g again. So it's going to be 3 minus, so I'm going to put a bracket here because I have two terms here. Then get it out from the bracket, I'm going to have 3 minus 3 plus x, which means you need to multiply it. Minus minus become a plus here. 3 minus 3 you'll get 0. So finally you have the answer of x. Question B, we have a function f which is equal to 4 plus 2x, and then we have function g which is equal to x squared. So for the first one, we're going to solve for the composite function of fgx, which means we're going to insert the function g into the function f. So the function g is x squared. We're going to insert the x squared into the x of our function f here. So 4 plus 2 bracket x squared. So multiply it. So finally we'll have 4 plus 2x squared. For the composite function gf(x), we're going to insert the function f into the function g. So fx is 4 plus 2x. This is the one that we're going to insert into our function g here. So we are going to get something like this: 4 plus 2x bracket with a square. This means we have two brackets of this. Then in order for us to solve it, then we need to do the expansions. So what you're going to get, 4 times 4 is 16 plus 4 times 2x, which is at x plus at x plus 4x squared. So I'm going to arrange it. So I'm going to get 4x squared. So at x plus at x, I'm going to get 16x, and then plus with the number 16. Now for the f square here, composite function, this means we're going to insert the function fx into the function f again. So fx is 4 plus 2x. So I'm going to insert this 4 plus 2x here into the x in the function f. Expand this, then I'm going to get at plus 4x. So finally I'm going to get 4x plus 12. This 4 plus 8, I'm going to get 12. And finally the composite function of g square x, which means I'm going to insert the function g into the function g. The function g is x squared. I'm going to insert this in the x of our function g again, which this is what we're going to get. So multiply the power, then we're going to get x to the power of 4. C, I'm going to have the function fx is equal to x plus 4, and then I have the function gx, which is equal to 6 over x. So for the first one, I'm going to solve for the composite function of fgx, which means we are going to insert the function g into the function f. So the function g is 6 over x. Then we're going to insert this into the x in our function f, which is going to be 6 over x plus 4. Then for the composite function of gfx, which means we're going to insert the function f into the function g. So our function f is x plus 4. So we're going to insert the x plus 4 into the x in our function g, which will become 6 over x plus 4. And for the composite function of f squared, which means we're going to insert the function f into the function f again. So the function f is x plus 4. Then we're going to insert this x plus 4 into the x in our function f, which is going to be x plus 4 plus 4. So finally, we're going to get x plus 8. And for the composite function of g squared, which means we're going to insert the function g into the function g again. So function g is 6 over x. So we're going to insert this 6 over x into the x in our function g, which will become 6 over x here. This is 6 divided by 6 over x. So this is means 6 times x over 6. Then I cancel the 6. Then finally I will have the answer of x. D, we have the function f, which is equal to x minus 5. And then we have the function g, which is equal to 1 over x minus 1. So we're going to solve for the first one first. The composite function of fgx, which means we're going to insert the function g into our function f. So the function g is 1 over x minus 1. So we're going to insert this into the x in our function f. So 1 over x minus 1 minus 5. to combine this into 1, so because this is a fraction, so you need to equalize the denominator. So 5 is mean 5 over 1, so to equalize the denominator, then I need to multiply it with x minus 1. So what I'm going to have here next is 1 minus 5 x minus 1 over x minus 1. I can combine these two together now because now they are having the same denominator. So it will become 1 minus 5x plus 5. As you expand this, so the minus will become a plus here over x minus 1. So next, 1 plus 5, you're going to have 6 minus 5x over x minus 1. And for the composite function of g, f, x, which means we're going to insert the function f into the function g. The function f is x minus 5. So x minus 5 is the one that we're going to insert into the x in our function g. So it will become 1 over x minus 5 minus 1. So it will become 1 over x minus 5 minus 1, you're going to get minus 6. So 1 over x minus 6 is the composite functions for the GF. And for the composite function of f squared is going to mean you're going to insert the function f into the function f again. So it will become, so function f is x minus 5. We're going to insert this into the x in our function f. So it's become x minus 5 minus 5. So finally it will become x minus 10. Now move to the last one, g squared, which means we're going to insert the function g into the function g. So function g is 1 over x minus 1. So once we insert it, the x here will become 1 over x minus 1 minus 1. So in order for us to solve these things, then we need to equalize the denominator before we are able to subtract it. So we're going to so 1 is mean 1 over 1. Then both of it we're going to multiply it with x minus 1. So this here is also mean 1 divided by 1 minus, so we have a bracket x minus 1 there, over x minus 1. So I can combine these two together now as they are having the same denominator. So here we're going to have 1 minus x plus 1 over x minus 1. So this is the same as 1 times x minus 1 over 1 plus 1 here will become 2 minus x. So finally we're going to get x minus 1 over 2 minus x.